Thank you, Kevin, and thank you to Lean Construction Island for this opportunity to present to you today. So today we're going to talk all about BIM, or Building Information Modeling, and how it applies to lean construction. Kevin introduced me already, so I'll just skip over this. But just wanted to say our company, ArcDox, have been working with project teams and businesses and individuals for the last 7 years to help implement BIM through consultancy, production, support and training services. So hopefully we can bring some of that experience to the discussion today. So in simple terms, BIM is about information about buildings or built infrastructure. And I think we can all agree that without information, nothing happens. You can't build anything without information, you can't maintain or operate anything, you can't even transact in buildings without information. So information is very important, it has value, and it's an asset that should be carefully considered and looked after. I think we can also all agree that the quality of information affects performance and outcomes. So if you have good quality information, things normally go well, and if you have poor quality information, things usually don't go so well. So I suppose that brings me on to how do you define quality information? I mean, I would define it as information that is digital. In other words, it's information that can be used and reused by many people. It's searchable, it's accessible, it's accurate, and it's useful. In other words, you have it in time and it's ready to be used when you get it. So I don't think many people would disagree with those points either. The problem is building information as we know it in the construction industry today is the exact opposite of what I've just said. It's predominantly paper-based. It's very difficult to search or query. It's highly unlikely that it's accurate because of the way it's produced and when it's produced. And in its static format, it's very difficult to keep it up to date. And very quickly the information becomes redundant. And things don't have to be that way. We live in the digital information age, and in other areas of life, we've just come to appreciate and expect better ways of working with information. So when you want to book your next holiday, for instance, you don't want to sit in the travel agents on a Saturday morning paging through a printed copy of the flight schedule of every airline that flies to your destination. You want to go online, enter your destination, push a button, and immediately present it with the most accurate, latest flight information from a number of airlines, a number of price options from different travel agents. You want to make a selection, you want to put in your credit card details, and you want confirmation straight away that your seat is booked. That's just how we expect to work with information in other areas of life. But in construction, if you want to find out something about a building, you've got to go and spend half a day in a storeroom full of lever arch files, paging through stuff. And even if you found the information, you probably wouldn't trust that it's the latest or most accurate information. So you'd end up going to survey the thing anyway. So I suppose today is about how do we bring construction into this digital information age. When you look at the information asset, and when we talk about an asset information model, we're not talking just about a three-dimensional model. We're talking about graphical detail, non-graphical detail, and documents. And when you look at the life cycle of information, what happens is during the delivery phase, a lot of time and money is spent sort of putting together this information, producing it, collating it, etc. Some of it during design stage, quite a lot of it during construction stage. But then when you hand over all this information to the building owner or the operator, the information enters the cycle of continuously degrading and depleting because it's in a static format that can't be kept up to date, and it goes missing, etc. Now obviously this isn't an ideal situation for any building owner, and many sort of more informed owners are now beginning to implement digital information strategies based on international best practice in asset management, or ISO 55000, which requires a sort of an information management strategy. And the whole purpose of the strategy is to turn the tide on this information and make sure it's continuously upgrading and increasing. Now obviously, the sooner you move that line towards the beginning of the process, the less it's going to cost you. In fact, if you can move that line right to the beginning, it will cost you nothing because people have to produce the information anyway. You're just asking them to do it in accordance with your strategy. The value that having a digital information strategy would bring to your project is obviously highest, the sooner you can move that line to the beginning of the project. Now it's interesting to me that a lot of the discussion around BIM is it's usually amongst designers in the design stage, and rightly so. I suppose a lot of the discussion around lean is around construction stage, but nobody really seems to be taking a holistic view of the life cycle of the information asset. The problem starts with the way in which we produce information in our industry. It's predominantly paper-based, even though we're using a lot of technologies like CAD and Excel and etc. At the point of exchanging the information with other people, it's usually printed on paper, and that's the copy that you get to work with. So we're talking about multiple documents that have to be manually produced, manually coordinated. There's a lot of duplication of effort between all the different types of documents. There's a lot of abortive work. There's excessive checking. It's prone to human error. It's labor intensive. It's costly, and it's time consuming. So it's problematic to start with. But we have another problem. We work in a very very fragmented industry, broadly broken down into planning, design, construction, and operations. But there's so many stakeholders involved in projects, all of which have their own business interests and the own way of doing things, and this ends up creating a complicated series of transactions of information between all these parties at different stages of the project, to the point where the collective knowledge or intelligence of the building information that's being produced is almost impossible to get to, because it's stored in different places and on different companies' servers and different people's PCs, or even some of it in people's heads. So I suppose the vision of BIM is that we'd get to the point one day that we could describe one building by one database of information, and that people would be required to input information into that database as you go through the cycle of projects. And when you're looking for something, you would just go to that database and you get the latest and greatest information. So I say that's the vision of BIM. We're not quite there yet, but that's where it's going. For those of you who haven't come across BIM before, but basically BIM is a process of building a virtual building in software. You literally assemble the building from objects that represent their real-life counterparts. And the important point here is it's not just 3D geometry. Every object is a container or placeholder, if you like, of all the information about that component of the building in a digital format. And the immediate benefit, obviously, of working in this way is that you have this virtual building and everybody can look around it, walk around it, make sure things are going to work and fit, and have a full appreciation of what the building is. Now, you can still get the traditional outputs from a BIM process, such as drawings and details and schedules, etc. But the important point here is that these aren't drawings that are manually drafted. These are views that are extracted or derived from the model. So the usefulness of BIM is that you only put the information in once into the model, and if you need to make a change, you only make the change once in the model itself. And every document that's derived or extracted is automatically updated. So it's a far more efficient way of producing information and an easier way of working. Now I want to make the point that you don't sort of add BIM to a traditional process. You don't say we're going to do the project, we're going to add BIM. Basically, it's an alternative methodology. The traditional process is where the intellectual and productive input goes into producing multiple documents, whereas in BIM, the methodology is to, the intellectual and productive input goes into building the virtual building. Now, you can still derive the documents from that process, but the one is a very time-consuming and costly process, as we've said, and the other is a far more efficient way of producing better quality information. And the reason I'm sort of laboring this point is because we've seen over the last few years a lot of people practice what I would call pseudo-BIM, and that's where they continue to develop the designs in the traditional methodology, and in the corner of the office somewhere they got some poor guy trying to frantically convert everything back to a model. And now obviously if you do BIM that way, you've just taken a process that is slow and time-consuming and costly and added something on top of it. Whereas if you do BIM properly, it's going to be more efficient and achieve savings. So would say watch out for pseudo BIM on projects, and there's a lot more of that happening than you would imagine. In 2011, the UK government set out a strategy to make BIM mandatory on all public projects by 2016. So that's in play now. And in that strategy, they defined different levels of BIM maturity. Level 0 being just CAD, level 1 being a mixture of 2D and 3D, but following some standards. Level 2 is where each discipline or supplier is working in BIM, but in a separate model, which can be federated together. And level 3 is the nirvana I spoke about earlier, where you have one database of information, so an integrated database or collection of databases that people are feeding information into. Now, for contractual and insurance reasons, we can't do level 3 yet. So if anybody says they're doing level 3, beware. But the UK government, I suppose, already working on their level 3 strategies through a program called Digital Built Britain, so that's worth following. The important point here is that all of this is focused around standards, and we're going to talk a little bit about standards later. So just graphically, what does that look like? At level 2, you have separate discipline models. Each discipline is using their model to produce their documentation, but you can bring those models together in what's called the federated model. And in this federated model environment, you can check that everything's going to work and fit together, and software will even automatically find clashes between items within your model. So the whole 3D coordination becomes a lot more easier to do. Now that you have this virtual model, you can do things which you couldn't really do before. You can link every object in the model to your construction program and carry out visual sequencing to look at issues of logistics, health and safety, etc. in this virtual environment, so you can resolve issues far earlier. You can, that's called 4D BIM. You can link every object in the model to a cost database and let computers do what computers do really well, which is count stuff quickly and accurately. But it means you need estimators that know how to work with model information, or 5D BIM. You can analyze this virtual building. You can analyze it for structural analysis. You can analyze it for energy performance. And the whole point of analysis is to try and optimize the design and come up with the best solution and test multiple iterations of the design before you build it. And lastly, in this environment, you can capture all the information that the facilities managers and operators will need to effectively operate their building in the future, such as maintenance periods, warranty periods, everything like that. So that's called 7D BIM. So those are the different dimensions of BIM, or the different uses of BIM, if you like. I think it's useful to take a minute to talk about what your clients want. Construction clients want better outcomes on their projects. And by better outcomes, I mean they want better buildings, built quicker and built cheaper. And it's interesting when you look at the UK Construction 2025 targets, you know, that they've said that they want to have 50% better performing buildings, and they're going to measure that by the amount of carbon they emit, so 50% less carbon. They want buildings to be delivered 50% quicker, and they want buildings to be delivered 33% cheaper. Now, whether you agree with those targets or not, I suppose the important point for us in Ireland is if the UK and other markets are striving towards those targets, and we're not, we're very quickly going to become uncompetitive. From a client's point of view, the first thing they want to really understand is what is it that they're getting? What is the building going to look like? Will it suit their needs, etc.? So they want to understand the scope. They obviously want to understand when they're going to get it, with the time. They want to understand how much it's going to cost. They're really interested in quality. Is it going to be well designed, well constructed? How much will it be to maintain and operate? Clients are really interested in getting value for money. And ultimately, clients are interested in certainty. For most clients, building or constructing buildings is not their core business, so they want their risks to be effectively managed by the professional teams that they employ. Now, you might say, if that's what clients want, what's this got to do with BIM? Well, the 3D aspects of BIM, the fact that you have this virtual building and you can take clients around the building, and it gives everybody a much better understanding of the scope of the project. The 4D aspects of BIM, or sequencing and logistics, etc., give everyone a much better understanding of the time. The 5D aspects of BIM in terms of quantity takeoff and cost checking gives everybody a much better understanding of the costs. The 6D aspects of BIM, or the analysis, be it structural analysis or energy analysis, etc., is all to do with achieving better quality buildings. And the 7D aspects of BIM is also a quality issue, in my opinion. It's about giving digital, accessible, accurate data about the building to clients at the end to help them maintain and operate their buildings. Okay. So I can tell you this from our experience: clients don't want BIM as such. What they really want is all the things that BIM can offer. And I suppose clients are just expecting more and more that the project teams that they employ would offer this to them. But ultimately they want better buildings, built quicker and built cheaper. And you might have a discussion about whether that's even possible. I suppose the traditional response to that is you can't have all three. If you want something better, you have to pay more for it, or you have to spend more time at it. And I suppose that sort of thinking is based on the incorrect assumption that you can't do anything about the process. So what we're talking about today is improving the way we do things and cutting out a lot of waste and making the whole process far more lean. And if you do that, then obviously you can convert some of that waste back into quality and value. And there's a lot of waste in design and construction. And I won't read through this whole list of things, or you can read through it yourself, but what I will say is every one of those things is happening on projects all the time. And every one of those things costs a lot of money. But not one of those things adds any value to the building itself. So therefore, by definition, all of that is waste. And organizations that measure these kind of things, like the Lean Construction Institute, for instance, would say that over 30% of the cost of construction is waste. And that's amazing to me that as an industry, as designers would be haggling for a 1% increase in the design fee, or as contractors we might be haggling for a 1% increase in profit margins. But nobody seems to be doing anything about this enormous percentage of waste. But personally, I don't think clients want to pay for that waste. They'd far prefer to convert some of that waste back into more value or more quality. And at the root of all those things listed on the left-hand side there is poor quality information. And that's why we feel BIM is going to have such a significant impact. It's not everything, but it's going to have a big impact on lean construction. Another way to look at this is where we spend money in construction. For every euro we spend in design, we spend about 20 euros in construction and about 60 euros in maintaining and operating buildings. I like to turn that around and say, if we just spent a little bit of extra time at the beginning in the design phase, getting the building right in this virtual building environment, coordinating the design, resolving any issues before we go to construction, and going to construction with digital data that the contractors can immediately use and process without having to spend weeks printing out drawings and marking them up with highlighting pens, then we should avoid a lot of the waste that typically happens during construction and get about 20 euros of value in the construction phase. And by designing buildings and testing them in this environment with performance in mind, and also handing over useful, digital, accurate, accessible data to the operators, you should get about 60 euros of value in the operation phase. So the key message there is the right time to invest in this process and BIM is as early as possible in the design stage, because that's where you would get the highest return on that investment. So I hope that short introduction gives you an idea that BIM is a far more efficient way of working, and therefore it's a lean method of producing, managing and exchanging information that fits perfectly into the whole lean construction philosophy. And no matter what your role is on a project, you need information to do your job, and in doing your job you're producing information that other people will need to do their job. So, and to make good decisions and to get good performance, you need good quality information. And going back to my earlier definition, that's information that's digital, searchable, accessible, accurate, timely and ready to use. And if we just quickly look at the principles of lean construction and how that might apply to producing, managing, and exchanging information, and where we might achieve a lot of savings or reductions in waste, just in transport, in exchanging information, digital information versus paper information avoids a lot of duplication and effort. In inventory, the way we use information and store information, and the ability to reuse information for future projects, etc., is far easier in a digital environment than it is in a paper environment. In terms of motion and moving people around, with this virtual building and the physical and the model, you can actually use a lot of technology such as immersive web meetings and bring the expertise into the model from all around the world, if you like, versus people having to meet in a meeting room with a printed copy of paper drawings. So there's a lot of potential savings there. Updating information. We all know that the designs change and buildings have to be updated. As I said earlier, if you make a change in BIM, you make the change once, and that change is automatically reflected in all the documents that are extracted or derived from that change, whereas waiting for that change to be reflected in the manual process it would take far longer. Processing information. Now, if you receive digital information versus receiving paper-based documents, and I would count PDF files as paper-based documents because you can't process them. You still have to print them and read them with your eyes. So, but if you receive digital data, you can immediately use it, immediately process it, and get on with your job. In the traditional way of working, we see too much information being produced too early by the wrong types of people, and it results in a lot of rework. And I think BIM offers many opportunities for the earlier engagement of the people who know how to construct and fabricate stuff. In terms of defects, this idea of building the building twice and resolving the design issues and coordination issues in the virtual environment rather than doing that on site much later on in the process would save enormous amounts of money. And we have highly skilled people in the construction industry, but too much of their time is being spent working through mundane manual-based or paper-based processes. So I think BIM offers many opportunities to get rid of the mundane stuff and let people do what they're really good at. So a question that maybe we can raise in the question and answer time for the lean construction community is, do you think lean can work properly without BIM? I mean, I know it's been working without BIM, but I think BIM really brings a lot to the discussion. So what's the catch? It all sounds good. There is a catch, unfortunately, and this is the fact. Everything I've said up to now is not going to happen. It's not going to happen unless there's a clearly defined managed process put in place that requires every participant to make their contribution to the project in this way. So, we need a standard way of working. And just to say something quick about standards, standards are the reason things work properly. If I go back to my earlier example of booking your holiday online, the reason that works so well and it's so seamless almost is because of a standard called HTML. Now, as a user of the internet, I don't want to know the technical details of HTML. I just want to use it and it must work for me. But if you're a web designer making applications, you need to understand everything about the standards. And in the same way, as designers and contractors move from a paper-based environment to digital design and construction and BIM, the clients don't necessarily want to understand the technical details of standards, but the designers and the contractors really have to understand the standards if they want things to work well. From a client's point of view, they just want an easy BIM button. Like the internet, they just want it to work. Another thing to think about when you talk about BIM and standards is that BIM is both a process and a deliverable. I mean, building information modeling is a verb and it's something we do. Building information model is a noun. It's something we provide. It's the deliverable. So we need standards that cover both the process and the deliverable. I won't spend too much time on this, but for the process, we've got all the standards that are coming out of the UK, which cover the information management processes during the capital delivery phase, operational phase, handover, etc. And in terms of the deliverable, there's already international standards for data schemas, classifications, definitions, etc. So I suppose the point is we don't have to reinvent the wheel. Everything's there. The British standards on process are currently becoming ISO standards, and the Uniclass classification system that they've developed in the UK it complies with the ISO standard for data classification. COBE, which is an information exchange format for facilities management, which is an end deliverable, complies with the ISO standards. There's standards for data security, and all of this is being driven by international best practice for asset management, or ISO 55000. So all the standards are there, all the guidance is there from the UK. It's all been developed for us. We just have to start using it. Is a key point. I want to spend just a few minutes on this particular standard because I think this is the one that will apply to most people in design and construction, but it's a specification for information management for the capital delivery phase. It requires a few key things to happen. It requires the client to produce what's called an EIR, or Employer's Information Requirement. It requires people to be pre-qualified for their capability to participate in the project through a series of questions in PAS 91. It requires a few commercial things to happen. There has to be a contract, so there's a BIM protocol that is appended to everybody's appointment or contract. Somebody has to be put in charge, a project information manager for both design stage and construction stage, and there's an outlined scope of service for that. There's some issues of PI insurance to deal with. A digital plan of work has to be put together to set out who's going to deliver what information, when they're going to deliver it, and what level of detail and information is going to be there. That's called the digital plan of work, and in the UK they've developed a handy free tool that you can use to do that. When you're tendering on a project, whether you're a designer or a contractor or supplier, you have to produce what's called a pre-contract BIM execution plan, which is a document that sets out how you're going to respond to the employer's information requirement. And the contents of all these documents are actually specified in PAS 11922. You also have to provide BIM capability assessments as part of your tender. Once you get appointed, the project team together will put together what's called a post-contract BIM execution plan, where the whole team together sets out how they're going to deliver on the employer's information requirements. You have to set up a common data environment, a central repository for all project information, which is carefully managed and controlled. And ultimately, the employer's information requirement will define the BIM deliverables, which will include COBE, which is the exchange for FM, or facilities management. It will include classifications such as Uniclass and possibly soft landings, which would keep the design team or construction team on board for a couple of years into the project to help people use the building properly. So that's what the standard sets out. At first it might look complicated, but I suppose I'd say keep calm. It's really not rocket science, and in fact lots of that is what we should be doing anyway if you're doing good project management or good design coordination. So we're documenting the requirements and responsibilities. We're probably doing that already in the employer's information requirements or the digital plan of work. We document how the team is going to deliver through the BIM execution plan. We're making it contractual through the BIM protocol. We're putting someone in charge, an overall project information manager, and individual task team information managers for each discipline. We're checking that everyone's capable through capability assessments. We're keeping all the information in a central, well-organized place, the common data environment. We're making sure all the data is well-structured through COBE, IFC, Uniclass, etc. And rule number one, make sure nobody is practicing pseudo-BIM on the projects because it just causes problems. So there's a couple of acronyms you need to learn and get used to there, but it's quite simple. If you follow those 8 steps, you'll achieve a good BIM project. There's lots of tools available to help. The Royal Institute of Architects in Ireland have put together 2 template documents to to assist employers to help to write their EIRs and also assist project teams to write their BIM execution plans. In the UK, the NBS have made available a free toolkit online which helps you develop your digital plan of work. The Construction Industry Council in the UK have got the BIM protocol document, they've got the scope of service for information management and guidance on PI insurance, and the Construction Project Information Committee have a number of templates that you can use, and specifically the BIM capability assessment forms. And what I would say on the last item there is, you don't have to wait until the next tender comes out and for the BIM requirements. You can take these forms and you can begin to assess your company for its capability and begin filling the gaps before the tender comes out, because you know what the questions are going to be. And when you look at all these things that we've just briefly covered and the things you need to know to be BIM Level 2 compliant, you realize very quickly that very little of this has to do with software. Some of it does, but it's mostly a project management issue. But the last two things, the ability to receive, open, navigate, query, analyze BIM data, you can do that with free software. So for many people in the industry, if you're not producing software, if you're just using it, you can use free, easy-to-use tools. But obviously the last item, for those who are producing information and managing information, you do need a new set of skills and a new set of tools to do that. So in summary, I hope that's given you a good overview that BIM is a process, not software. It's about creating and sharing information in a more streamlined way. It's about improving the collaboration and communication and getting better quality information to try and reduce some of the risk and waste in construction. In other words, we want better outcomes. And it's all about the information, or the I in BIM, and how that's used by different stakeholders. Just briefly, if anybody needs help with this, as I mentioned earlier, ArcDox have been providing services to project teams, consultancy services, production services, training, and support services directly on projects, or just for if your company wants to implement BIM, please contact us. And I just wanted to take one slide to let everybody know about the Construction IT Alliance, which has really become the meeting place for BIM in Ireland, if you like. The Alliance is a not-for-profit organization which has been promoting the use of IT in construction for over 12 years now. There's about 20 industry stakeholder groups that are represented. There's about 6,000 members on our LinkedIn group. We've been having a series of breakfast meetings for the last 5 years, specifically on BIM, and annual conferences. We've recently established 9 regional groups around the country to try and get the message and help people upskill in that area. There's an annual conference coming up in November. CETA have also been appointed by Enterprise Ireland to do some research around Ireland's capability around this area, and more recently they've established a National BIM Council. So with that, we could go to questions.